In this video, I'm going to run through some examples of Gauss Jordan elimination with two variables. So let's look at this linear system here. First equation is minus x plus 2y equals minus 3, and the second equation is 4x plus 2y equals 2. In matrix form it would look like this, with the matrix minus 1, 2, 4, 2 multiplying this vector xy is equal to this vector minus 3, 2. And to solve this system for x and y, we can perform Gauss Jordan elimination, and to do that we write down the numbers in the matrix and then draw a vertical line and then write down the numbers in the vector on the right hand side of the equation. And we're going to perform elementary row operations on this system to change the numbers on the left hand side of the line into reduced row echelon form, which in this case is going to be a 1 here, 0 here, 0 here, and 1 here. And then whatever happens to these numbers on the right hand side, that will give us our solution. So first step, we want a 1 in this position. So one way to get that would be to divide that entire row by minus 1, in which case we'll have 1, minus 2, 3, and then we'll just write down the second row again. Next step, we want to get a 0 in this position here. So to do that, if we take the second row and subtract 4 times the first row, we'll be able to get a 0 in this position. So what we do is we'll just write down the first row again, because we're not doing anything to that in this step, and then the second row will replace it with 1 times the second row minus 4 times the first row. So that will be 4 minus 4 times 1, which is 0, 2 minus 4 times minus 2, which is 2 plus 8, which is 10, and then 2 minus 4 times 3, which is 2 minus 12, which is minus 10. So that's that step taken care of. In the next step, we want to get a 1 in this position, and so one way to do that is to divide this entire row by 10. So we're not doing anything with the first row in this step, so we'll just write it down again, and then we're dividing that second row by 10, so we'll have 0, 1, minus 1. And then the last step, we want to get a 0 in this position, and so to do that we can take this entire row and add on 2 times the second row. So let's do that. So we're not doing anything to the second row in this case, so we'll just write it down again, but the first row now will be replaced by the first row plus 2 times the second row from the previous step. So we'll still have 1 here, and then we'll have a 0 here, and then we're going to have 3 plus 2 times minus 1, which is 3 minus 2, which is 1. Okay, so there's our solution. Looks like x equals 1, y equals minus 1. So let's just check that that's correct. So going back to our original equations, we have minus x plus 2y. So if x is 1, we're going to have minus 1 plus 2 times y is minus 1. So we'll have minus 1 minus 2. So that's minus 3. And that's what it's supposed to be. So that's correct. And then the other equation, 4x, so 4 times 1 plus 2y, so that's 4 minus 2, so that's 2, and that's what it's supposed to be as well. So it looks like we've got the correct answer. So that's one possibility, is a unique solution to this system. and geometrically that's equivalent to two non-parallel straight lines that intersect in one place. Gives us a single solution. Another possibility is that we could have two parallel lines that have no solution. And so let's see an example where that's the case. So if our system looks like this, so this would be minus x plus 2y equals minus 3 and 2x minus 4y equals 2. Let's perform Gauss Jordan elimination here and see what happens. So first step is to divide the first row by minus 1, just like we did in the last example, and leave the second row alone. And then we're trying to get a 0 in the bottom left position, so we're going to take the second row and subtract 2 times the first row. So first of all, we'll just write the first row again, and then second row, replace it by the second row minus 2 times the first row in the previous step. So we'll have a 0 here, and we're going to have minus 4 minus 2 times minus 2, so that's minus 4 plus 4, which is 0, and then we're going to have 2 minus 2 times 3, which is 2 minus 6, which is minus 4. So we've ended up with zeros in the second row here. There's a 0 here and a 0 here, and yet we've got something that's not 0 here. And so this is telling us 0x and 0y equals minus 4. Well, that can't happen. So we stop at this point, and this means there's no solution. So geometrically this is equivalent to two parallel lines that don't meet and don't cross, and so there's no solution. So that's the second possibility. The third possibility is if we have two parallel lines, and not only are they parallel, but they're actually on top of each other. So in essence, we've really only got one line, and so there's an infinite number of solutions there because they meet everywhere, if you think of them as two lines lying on top of each other. So as an example, let's look at this system here, and again perform Gauss Jordan elimination and see what happens. So first step, just like in the other examples, we'll divide that first row by minus 1, and then second step, we'll just, sorry, before I go to the second step, I'll just write the second row again, and then the second step, we'll write down the first row, and then the second row. To get a 0 here, we're going to take the second row and subtract 2 times the first row, so we get 2 minus 2 times 1, which is why we get 0 here. And then for the second column, we've got minus 4 minus 2 times minus 2, which is minus 4 plus 4, which is 0. And then on the right hand side of the line, we're going to have 6 minus 2 times 3, which is 6 minus 6, which is 0. So if we end up in this situation here, where we've got zeros on the left hand side of the line and also a 0 on the right hand side of the line, then that's telling us that we've got an infinite number of solutions because we've reduced our system to a single equation. So this is an infinite number of solutions. Geometrically, it's two lines on top of one another, and the way we could write the solution is we've only got a single equation now that's saying x minus 2y equals 3. And so if we write this in parametric form, we could set y equals a scalar t, and then x will be 3 plus 2t. And that's a way to write the solution set in this example. Y we can set to any number, and x is equal to 3 plus 2 times t. So for example, if t was 0, then one solution would be y equals to 0 and x equals 3. Another solution might be y equals 1 and x equals 5. So t can be anything, so there's an infinite number of solutions here.